Hello everyone, in this video we're going to translate English phrases to mathematical symbols and vice versa. The objectives that we're going to have in this video would be first to familiarize the terms used in translating algebraic expressions. We're going to familiarize the symbols, the basic symbols, the plus, the minus, the times, and the divide. Then after familiarizing, we're going to translate English phrases to mathematical symbols and vice versa. In here, I have some English phrases, words, or keywords that are very important, particularly if we are going to have or if we will be dealing with word problems. So we have here the addition, the subtraction, the multiplication, and the division. These are just some. Actually, there's still a lot. There's still a lot of keywords. I only listed here some of the commonly used keywords. Now, no need for you to memorize everything, but rather just familiarize this one so that you will know on how to use this one, when to use this one, particularly in a particular expression. For addition, we can use the sum of, added to, increased by, plus, more than, greater than, exceed by, more. So these are the commonly used, particularly if we're going to use the addition. Next is the subtraction. We have the difference of, diminished by, decreased by, minus, less than, subtracted from, diminished by, and less. And again, there's still a lot. We'll be talking more about this one because even a single word used would mean differently, because there would be sometime the arrangement will be different if you're going to use different phrases or keywords. And for multiplication, we can use the product of, multiplied by, of, times, twice, thrice. Now, this word of, when are we going to use the word of? Now, sometimes we use the word of particularly if we will be multiplying fraction. For example, 1/2 of, 1/3 of. So meaning, this of here indicates that we're going to use the multiplication. So the times, the twice, when we say twice, we're going to multiply it by 2. The thrice, we're going to multiply it by 3. And many more. Now the division, when we say division, we're going to use the keyword the quotient of, divided by, all over, ratio. And we can also use the word split into. We have also the exponent, so we can use the square or the cube. When we say the square, we're going to raise it to the power of 2. And when we say cube, we're going to raise it to the exponent of 3. Now, I want to give emphasis on this particular words because, as what I have mentioned earlier, even a very short word would already mean a lot. So, for example, 5 more x, 5 more than x, 5 added to x, 5 greater than x. So, this one here, the arrangement will be different. So, when we say 5 more x, so as is, what comes first would be the one to write first. So 5 plus x. But when we say 5 more than x, 5 added to x, 5 greater than x, then the arrangement will be different. That will become x plus 5. But what if I will say 5 added by x? So when we say 5 added by x, we're going to add x to 5. So that would be 5 plus x. Again, I want to emphasize that this is 5 more than x, 5 added to x, and 5 greater than x. Again, this is very important because the arrangement or the order of the expression or the terms or the words or the symbols are very important. Now, same with the subtraction. So, when we say 5 less x, so as is. So, first is the 5, then minus x. But when we say 5 less than x, and 5 is subtracted from x, so the arrangement will change. Now, why is this important? Because we all know that only addition and multiplication are commutative. Subtraction and division are not commutative. So when we say commutative, even the arrangement will be changed, you'll get the same sum or product. But in subtraction and division, if the sequence or if the arrangement is changed, the answer will also change. Again, always remember that in addition and subtraction, you must be careful about the order of the number. Again, I am giving emphasis and I'm giving importance on this one because these are the common mistakes that we encounter. So let us have some examples now. We are going to translate English phrases to mathematical symbols. So we're going to translate each into algebraic expressions. Let's have first the English phrases before we're going to proceed with the English sentences because they are both different. Now take note, if there is a certain number, if the number is not given exactly, we're going to represent as x. So all the variables will be represented as x. So I have here 9 phrases. So we're going to translate these 9 English phrases into algebraic symbols. And first thing we're going to do is that we should know the keywords. Okay, the keywords here are very important so that it would be easy for us to translate it into symbols. So these keywords are very important so that you'll know what to do or what operation you're going to use in translating. So the first example is the sum of m and 8. So the keyword that we have in here is the word sum. Okay, the sum here represents the operation addition. So it is the sum of m and 8. So therefore, in translating this one, we have m to be the variable, the sum, so we're going to have the plus, and 8. So we have m plus 8. Next, 7 minus a. The keyword is minus. So we have 7 minus a. Next, r exceeds by 20. So the word is exceeds by. So we have r plus 20. Next, the product of 9 and n. So the keyword is the product. So when we see product, it is multiplication. So we're going to have 9, the product of 9 and n. So 9 times n. Now, bear in mind that 9 and n, though we cannot see the operation there, the dot or the x or the parenthesis, it is immediately understood that if there are no or if there is no operation between two variables or between coefficient and variable, automatic, the operation is multiplication. So therefore, we have there the product of 9 and n, we have 9n. Next, y divided by 8. So our keyword is divided by, so we're going to use the division. So we have y divided by 8. We can have that bar or we can use the symbol division. So y divided by 8. Next is twice a number. So the keyword here is the twice. And when we say twice, we're going to multiply it 2 times. Okay, so twice a number, we will have 2x. Since we are going to twice a number, we don't know the number. We're going to twice a particular number, so we will have 2x, or we have there now the twice the number. Next is the quotient of a number and 10. So we have here the keyword would be the quotient. So when we say quotient, the operation would be division. So we have there the quotient of a number and 10. So we have 10, or the number is x, represented by x, divided by 10. Again, you can make use of the fractional bar to indicate division. So we can have there now x divided by 10. Next is 10 less B. So 10 less B, the keyword is less. So as what I have discussed earlier, when we say less, it is as is. You will not change the sequence, or you are not going to change the arrangement anymore because the keyword is only less. So we have there now 10 minus B. So that is 10 less B or 10 minus B. Next is 3/4 of a number. So 3/4 of a number, the keyword is of, meaning we're going to multiply. So we have the fraction 3/4 and the number which is x. So we have 3/4 x. So that's it. We were able to answer the 9 examples, but then this one here, it only include one operation. Now, how about more than one operation? So it's a bit complicated already, but then let us try to have examples about that. And now let us try to have another set of examples. Again, we're going to translate each into algebraic expression, and then again, we're going to express or represent x with a certain number. Now, the sum of twice a number and 7. Now, this time it includes already two operations. So, we're going to get the sum. The sum of who? So, when we say sum, we're going to use the what operation? We're going to use the plus. So, the sum of who? So, who are we going to get the sum? So, the twice of number and 7. So, we're going to get the sum of twice the number. So, twice the number is 2x and 7. So, we have already there the sum of twice a number and 7. We have 2x plus 7. So what you can see is a bit complicated already. So be careful in translating. Understand the phrases always. So understand, comprehend the phrase properly. Next, we have the product of 12 and a number decreased by 8. So as what you can see, the comma there is very important because this one here is a phrase and this one is another phrase. So we have here the product and decrease. So we have multiplication and subtraction. Now let us try to translate it first part by part. So the product of 12 and a number. So product of 12 and a number. So 12 times x. Now what are we going to do to the product of 12 and a number? We're going to decrease by 8. So decrease by 8 meaning we're going to subtract it by 8. So we have the product of 12 and a number decreased by 8 is 12x minus 8.
More than 4
Next
times
is
a
20 more than 4 times a number. So we have there now 20 more than. So when we say more than, as what I have mentioned earlier, when we say more than, the sequence or the arrangement will be changed. So first thing we're going to write is the 4 times a number before the 20. So more than meaning the word here there is plus because it is more than. But then more than the sequence or the arrangement will be changed. So we're going to write first the 4 times a number which is the 4x. So 4x plus and then 20 more than. So 20 more than, so plus 20. So we have there now 4x plus 20. So again, I'm going to give an emphasis about that one. When we say more than, the arrangement or the sequence will be changed. So we have there 20 more than 4 times a number. We have 4x plus 20. Next is the quotient of thrice a number and 15. Since it is a quotient, so we're going to write there the quotient or the division or the divide. So let us try to write first the quotient or the fractional bar. Now, the quotient of who? So who are we going to get the quotient of who are we going to divide? So the quotient of thrice a number. So we have thrice a number is 3x. And 15. So the quotient, meaning the divide. So the quotient of 3 times a number, 3x, and 15. 3x divided by 15. Next is 8 times the square of a number diminished by 4. So we have here the square and the term or the word diminished by. So when we say square, meaning exponent. So the exponent is 2. So what you can see, we have square of a number, comma, and then diminished by 4. We have 8 times the square of a number. We have 8 times x squared. Going back on the statement, we have 8 times the square of a number. Again, we use the variable x because that was in the instruction that we are going to use x to represent a certain number. Now, not unless if in the statement it was specified of what particular number. So we have here 8x squared. Now, this is diminished by 4. So again, when we say diminish, the operation will be subtraction. So minus 4. So we have 8 times the square of a number diminished by 4 is 8x squared minus 4. Now, how about we're going to the other way around? So, for example, here we're going to translate now mathematical symbol to English phrases. So, how are we going to translate these symbols into phrases? Now, bear in mind that there are so many ways on how to translate this one. It depends on how we are going or the usage of the symbol that we are using. There's so many ways, like for example, we're going to plus or we're going to add. We can use a more than, exceed from, or added by, or more, or increased by. So there's so many ways on how you are going to translate this symbol into phrases. Now, expressions are usually named by the last operation to be performed in the expression. Now, what does this mean? So, most of the time, not most of the time, not all the time, but most of the time, this is the situation. The expression is usually named by the last operation. Now, for example, this expression, so 2x plus 5. Now, what is the order of the operation? Using the PEMDAS, right? We're going to multiply first, then the last one we're going to add. So, therefore, we are going to name this one by sum. So, if you're going to translate this, we're going to translate it the sum of. So, this is what it meant. The last operation is usually how we name the expression. In here, the last operation is addition, so that is why we're going to use the sum of. Now, in here, what is the last operation? We have the subtraction or the difference. So, we're going to multiply first before we're going to subtract. Next, the last operation would be multiplication because using the PEMDAS, we're going to solve first those inside the parentheses. So, the last would be multiplication. In here, the same, using the PEMDAS, we're going to square first because PEMDAS, then the last would be subtraction. And in here we're going to get first, or we're going to divide because we're going to multiply first 5 and a by 4, so division. And in here, the last operation would be division because we're going to do first the addition on the numerator and the subtraction in the denominator. So in here, we're going to have 2x plus 5. We can use the sum. So the first statement that we're going to have is the sum of who? The sum of twice a number and 5. So we have there now the statement. Again, we're going to use the last operation to be the first or to name the expression. So we have here the sum of twice a number and 5. Now, it doesn't mean that this is the only answer that we're going to have. It depends also. It depends also in the construction of the statement. There are many possible answers on this symbol because there are so many ways on how to use the keywords, right? You just make sure that you have translated it properly. So in this symbol, we can say that this will be translated as the sum of twice a number and 5. Or we can also say, we can translate this one as 2 times x increased by 5. So we can also have that one as our answer, or that in that way we can translate it in that way. Or there's so many ways. We can also say 5 more than twice a number. Again, there is no exact answer or translation as long as you have translated it properly based on the given expression or symbols. Now, let's have another one. Let's have the second example. So, we have there the given symbol is x minus 3y. Let us try to translate this one. I will only give two examples on how to translate. We can have the difference of x and thrice y. So I use the difference because the last operation is subtraction. So the first thing that we are going to name the expression by the last operation. So we have the difference of x and thrice y. Also say because x and y are different number, we can also say the difference of a number and thrice another number. Now we're going to use the word or the term another to indicate that there are two different unknown, or there are two different numbers. Or we can also say a number x diminished by 3 times y. Again, diminish because the operation is subtraction. So you should again be familiar with those symbol, okay? Next, we have a squared minus 4b. How are we going to translate this statement? So we have square then. So in translating, we can say the square of a minus 4 times b. Now, how about another way of translating? We can also say, since it is subtraction, so the difference of the square of a and 4 times b. So there you have it. We have already answered 3 of the mathematical symbol, and we have already translated it into English phrases. Now, what you're going to do to the remaining 3 problems or the 3 symbols, I want you to answer that one. Now, I have attached the answer on the last part of this video. So all you need to do is just to pause this video first and answer this remaining mathematical symbol translated into English phrase.